Right, so I want to add one more dimension to what we've already been working on. These are called compound, write that down, please, inequalities. Meaning that we're putting some inequalities together. It's a way of writing it that's more compact and is more usable sometimes. So write this one down. Now, the first thing I want you to notice with this first problem is it says it's x minus 4 is less than 7 or 2x is greater than or equal to 12. It means we've got two situations happening here. We want to solve, graph, and write our answer in interval notation. So what I'm going to do is I'm going to solve each half separately. For example, x minus 4 is less than 7. I know my first step is to add 4. And so x is less than, and I miscopied this. This needs to be negative 7. Just make that quick correction, please. X minus 4 is less than negative 7. X minus 4 is less than negative 7. And when I add these, I get x is less than negative 3. Let me do the other problem here, the or. 2x is greater than or equal to 12. I know to divide by 2. Well, these inequalities are quite a bit easier so far. It's just 2 of them, 2 for the price of 1, you might say. So x is less than negative 3, or x is greater than or equal to 6. So that's my solution. With any or statement, I kind of have two possibilities there if it remains an or statement. And I'm going to graph negative 3, 2, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. Now, if I graph x is less than negative 3.
May I have your attention, please? All underclassmen with the last name with letters A through S can go to the auditorium to get their picture taken.
I'm going to put an open circle at negative 3, and it's all values less than negative 3. Or auditorium. X is greater than or equal to 6, so I'm going to shade that in. And so either of these will solve this compound inequality. The last thing is, well, how do I write that as in an interval notation? Well, I'm going to use a parentheses, negative 3, and infinity. My infinity sign is going to be on the left because the first one here points to the left. In other words, its value is less than negative 3, so we fall on the left of that, or. And I'll use a bracket for 6 because it can be equal to 6 in positive infinity. So that's the solution in interval notation. Putting an interval notation is not really that hard. Kind of looks like the graph, doesn't it? That's the way I kind of think about it. I want to give you one more example of an or compound inequality. And if you're looking at what I posted online, I'm going to skip down to number 3. So number 3 is 2x plus 9 is greater than 17. It's a lot better when I write what I say. And 5x plus 10 is less than 10. And this is an OR compound inequality. So we'll break it into 2 halves. 2x plus 9 is greater than 17. We'll work on that one first. I'll subtract 9 from both sides. 2x is greater than, and then 17 minus 9 is 8. Divide by 2. X is greater than 4. I'll just remind you, if you're watching this video, if it gets going a little too fast, you can always pause it and start it back. All right, so let's look at 5x plus 10 is less than 10. I'll subtract 10 from both sides. And I get 5x is less than 0. Divide by 5. And x is less than 0 divided by 5 is 0. So I need to graph it as well as write it in interval notation. Looks like I span 0 to 4, so maybe I'll go -2, -1, 0, 1, 2, 3, 4, 5. Both of these will be open dots because they're not equal to, they're simply greater than or less than. And if I graph x is greater than 4, I'll put an open dot here. And it's greater than 4, so it's all values larger than 4. And then x is less than 0. So I'll put an open dot there. All values less than 0. In interval notation, I'm going to be using all parentheses since there's no equal to's in here. It'll be negative infinity and 0, or 4 and positive infinity. Or graphs tend to graph, they have a tendency to graph apart. But we're actually going to look at some graphs that tend to graph together. If or kind of means apart, what do you think means together? Do what? As is not the word I'm really looking for. Not it means to multiply. If I say I'm going to send, who can I pick on? Maverick or Devin to the office to pick up my mail. I don't send them both, do I? Okay. Or if I say I'm going to send Logan and Aisha to the office to pick up my mail, both of you go, right? Okay, so apart means or. Together typically mean, apart means or. Together is usually we use the word and. So these compound inequalities will use a word and we typically like to write them in a more condensed state. So on that same handout, this is problem number 6. I want you to write it down. Okay, and remember we're going to graph. Actually, we're going to solve, graph, and use interval notation. Okay, number 6 is 2 is less than or equal to x plus 4, which is less than 9. Oh, that's a different looking inequality, isn't it? It's got 2 inequality signs in the same basic statement there. Well, it's just all together, and it's a compact way and a more condensed way to write this inequality. So let's see how that's going to look, okay? Notice this less than or equal to or less than here. These are both less than signs, and that's typical the way we would write a compound inequality, especially one that is an and type inequality. I'm going to break it into 2 pieces. Here's what I'm going to do. I'm going to say 2 is less than or equal to x plus 4, and x plus 4 is less than 9. Do you see what I did there? Just broke it into 2 halves. So I'm going to use the same things I always use to graph. I'm going to subtract 4 from, or to solve, I'm going to subtract 4 from both sides, and I'm going to get negative 2 is less than or equal to x. Those cancel. And here I'm going to do a similar sort of thing, subtract 4 from both sides. And I find out that x is less than 5. So if I join those back together, my x is in the center. I could write that solution this way as negative 2 is less than or equal to x, which is less than 5. That's a classic and statement. Let's think about what that's going to look like on the graph. It's actually going to kind of look like the inequality. See what I mean by that? Negative 2, negative 1, 0, 1, 2, 3, 4, 5. What I'm saying is negative 2 is less than or equal to x, which is less than 5. Now, the way I'm going to graph that, first of all, is I'm going to place dots on negative 2. I'm going to place a dot on 5. For negative 2, it's got to be a closed-in dot because it's less than or equal to, correct? But for 5, I'm going to use an open circle because that's just a less than sign. I want you to think about what this means. If I flipped this half around, this negative 2 is less than or equal to x. If I flip it around, I have to reverse my sign as well. I would say, okay, x is everything greater than negative 2, and x is less than 5. What that looks like is any value, because it's an and statement, between equal to negative 2 and all the way up to but not including 5 is the solution for that. And inequalities, and compound inequalities, will tend to have that look, where it's a segment with an endpoint on each end. Now, in my interval notation, the interval notation, you will be sure to write this down. It's a lot easier. We don't even have to deal with infinity signs because here's what it is. It includes negative 2 and goes all the way up to 5. Bracket because it includes negative 2. Parentheses because it does not include 5. But it goes all the way to 5. So that interval notation is simpler than the ones we did with infinity signs, especially the OR ones. We'll look at just one last example today in the examples we've had of compound inequalities. All right, so if you would write down this one, number 9. All right, so for this one, I've got -1 is less than 2/3 x plus 1, which is less than or equal to 5. What's the first thing you see that you don't like about that one? It has a fraction, yes. And remember, always when it comes to fractions, we want to declare fractions. The way I can do this, I have a 3 in the denominator. So I just need to multiply everything through by 3. Because it'll cause that 3 in the denominator 3 to cancel. So this would be rewritten this way. It would be -3 is less than 2x, because I multiply 3 times -1, got my -3. Multiply 3 times 2/3, my 3 and my 3 in the denominator cancels. I'm left with just 2x. Plus, don't forget I've got to multiply it times that 1. So 3 times 1 is 3, which is less than or equal to 15. Now, I've gotten rid of the fraction. That's by far the first thing I always want to do. I'm going to break it into halves. -3 is less than 2x plus 3, and 2x plus 3 is less than or equal to 15. Okay, I'll just use the same process as always. Subtract 3 from both sides. And I'll get -6 is less than 2x. Divide by 2. I'll be left with x, or -3 is less than x. So far, so good. Over here, I'll subtract 3 from both sides. I'll get 2x is less than or equal to 12 divided by 2. And x is less than or equal to 6. So if I put them back together for a compound inequality, it'd be -3 is less than x. X is in the middle, which is less than or equal to 6. If I graph that, I'll graph it this way. Close dot on 6. Open dot on -3. And it's every value not equal to -3, but greater all the way up to include 6. In interval notation, that answer then is just parentheses, -3, 6 bracket. And that's an inequality, a compound inequality that's an and statement.